Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope has recently uncovered thrilling new data on the Centaur 29P/Schwassmann-Wachmann 1, a truly unique object in our solar system with an orbit located between Neptune and Jupiter. This centaur, an icy relic of the early solar system, has captivated scientists with its unusual behavior erupting with bursts of primordial gas jets in a manner that is unlike any other known object. These unpredictable outbursts have puzzled researchers for decades, raising questions about the underlying mechanisms responsible for such unusual activity. This documentary will delve into the scientific significance of Centaur 29P, exploring its potential clues about the solar system's formation and examining how understanding its gas jets could pave the way for future research. Images captured by the James Webb Space Telescope's near-infrared spectroscopy camera reveal a series of gas jets erupting from the surface of 29P/Schwassmann-Wachmann 1, which is widely recognized as a standout example of centaurs, a fascinating group of celestial bodies straddling the characteristics of comets and asteroids. Centaurs like 29P are believed to be ancient remnants, largely unchanged since the solar system's inception, as they have remained distant from the sun's heat, effectively frozen in time. Over many decades, 29P's unique, unpredictable outbursts, occurring approximately every 6 to 8 weeks, have continuously drawn the attention of scientists seeking to understand these enigmatic objects. This latest data provides an unprecedented look into the nature of 29P's gas jets, offering potential insights into the composition and structure of materials that existed during the solar system's earliest stages. The frozen ices of centaurs like 29P may hold clues to the solar system's primordial makeup, preserved for billions of years due to their isolation. Understanding why 29P experiences such explosive, volatile activity could shed light on the chemical and physical conditions that existed long before planets took shape. Additionally, analyzing the emissions from 29P offers a unique opportunity to refine our knowledge of the processes that may drive the activity of similar bodies within and beyond our solar system. Researchers are particularly interested in how these findings can contribute to broader astrophysical research. The ability to detect and study jets from centaurs and other distant objects may unlock a new realm of understanding regarding icy bodies beyond the orbit of Neptune and the mysterious mechanisms that govern their behavior. By continuing to observe and investigate these gas jets, scientists hope to uncover valuable information not only about the past, but also about the potential evolution and future of the solar system's outer reaches. In this documentary, we will take a closer look at the scientific journey behind this discovery, its potential implications for understanding our cosmic origins, and the exciting possibilities it opens for studying centaurs and other enigmatic celestial bodies in the distant reaches of our solar system. In order to get away from the ice bodies that are part of the Kuiper Belt, which are situated beyond Neptune, 29P has been pushed into a new orbit that lies between Jupiter and Neptune. This makes it an uncommon object. When 29P is in its new vantage position, it releases gas jets at random intervals, which provides us with a one-of-a-kind opportunity to investigate its older materials. The majority of comets are known to acquire tails as a consequence of the sublimation of water ice on their surfaces, which results in the emission of gas. This phenomenon is well known. Despite the fact that the absence of water vapor in the jets that Webb saw was unexpected, it was nevertheless shocking because 29P is still too far away from the Sun for its water ice to evaporate. If Comet 29P is indeed emitting jets without the presence of water vapor, it necessitates a significant re-evaluation of the processes responsible for these outbursts. This unusual behavior highlights the need for a deeper exploration of the outgassing mechanisms of 29P, as traditional assumptions about cometary activity do not fully apply here. Notably, water ice, the usual driver of cometary jets, appears to be absent. Instead, gases with lower vapor pressures, such as carbon monoxide (CO) and carbon dioxide (CO2), are likely driving 29P's activity. This theory aligns with the broader scientific consensus, suggesting that 29P might be releasing these gases, which have likely remained unaltered since the formation of the solar system, preserving a snapshot of its original materials. Observations using the Webb Telescope have revealed that 29P emits multiple CO jets, which was previously unknown. These jets, originating from separate areas and pointing in distinct directions, indicate that CO and CO2 are likely being released from different regions of the comet. This discovery was further supported by 3D computer modeling, which suggests that the jet sources are indeed spatially separate. Despite the limitations of Webb's resolution, which prevents direct observation of 29P's nucleus, these findings support the idea that 29P could be a contact binary, a binary object where two smaller bodies have merged into one. This characteristic is comparable to Comet 67P, famously studied by the Rosetta mission, which also displays a dual-lobed structure. An intriguing aspect of these jets lies in the different boiling points of CO and CO2, hinting that 29P's surface might be composed of varied materials in different regions. The presence of such diverse volatile gases in distinct locations may partially explain 29P's peculiar behavior, rapid, sporadic eruptions occurring at various points on its surface. These bursts may result from the uneven distribution of gases and other volatile compounds. The variability in gas composition across its surface provides scientists with an invaluable opportunity to study the dynamic processes that govern ancient primordial objects in our solar system. In studying 29P's irregular eruptions, scientists can gain insights into the nature of contact binaries and potentially develop a better understanding of the complex mechanisms that influence these unique celestial bodies. This comet, with its strange, unpredictable behavior, thus offers an extraordinary glimpse into the physical and chemical forces at play in the early solar system, preserved in its ancient materials, and triggered by its unique composition and structure. A greater number of instances of 29P traveling inward from the Kuiper Belt have been seen. Because of the impact that large planets have on their orbits, a great number of centaurs experience modifications that are comparable to one another. As a result of these elements, they undergo transformations over time, which affect not just their behavior, but also their structure. It is feasible that centaurs will evolve into comets in the future. The proximity of these objects to the Sun results in the discharge of gases and dust, and the evaporation of their volatile constituents, such as carbon monoxide and carbon dioxide, as a result of the rising temperatures. In the course of time, the frequency of these eruptions rises, and the centaur begins to behave more like a comet, with characteristics such as the production of a tail as water ice sublimates. This is something that has happened to other centaurs in addition to 29P. Consider the centaur 2060 Chiron as an illustration. It was one of the earliest centaurs that was discovered to display behavior similar to that of a comet. Even though its activity is less regular, Chiron, like 29P, travels between Neptune and Jupiter and occasionally releases gas and dust. This is similar to the orbit of 29P. It is corroborated by the fact that 60,558 Echeclus, another centaur, has demonstrated abrupt outbursts, injecting gas and dust into space. This also lends credence to the idea that many centaurs are gradually but actively transitioning into comets. In contrast, the asteroid belt, which stretches from Mars to Jupiter, is filled to the brim with asteroids, which are objects made of rock and metal from the solar system. Asteroids, in contrast to centaurs such as 29P, do not release gas jets and remain immobile for the most part within their orbits that are rather constant. Comets, on the other hand, become significantly more active and explode at regular intervals as they get closer to the Sun. Due to the fact that their orbits are so short, typically lasting less than 200 years, their activity cycles are extremely predictable. According to what was mentioned earlier, 29P is situated in a unique zone that is situated between the comets and the asteroids. Although its outbursts are unpredictable and chaotic, it does discharge gas jets. This is due to the fact that it does not have the normal water-driven outgassing that is characteristic of comets. When a matter of fact, 29P is particularly active in comparison to other asteroids, which indicates that it is undergoing transformation and may eventually become a comet when it gets closer to the Sun. Centaurs offer professionals in the scientific community a one-of-a-kind opportunity to observe significant transformations taking place right in front of their very eyes. In general, the evolution of objects in the Kuiper Belt may be better understood with the assistance of the centaurs because they reveal key details about the mechanisms that are driving their transformation. This is because the centaurs expose the mechanisms that are causing the change. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.